So previously we have learned that in a triangle, whenever we have two equal sides, the angles opposite to them are equal. Now in this video, we're going to learn the converse of that. That is, if two angles of a triangle are equal, then their opposite sides are also equal. I repeat, see earlier what did we learn? We were given two equal sides, so we said that the angles opposite to them are equal. Now the other way around, if two angles are equal, then the sides opposite to them are also equal. So this is what we're going to prove in this video. So let's begin. So if two angles of a triangle are equal, then sides opposite to them are also equal. So let's say two angles are equal, choose any two angles. Let's say I choose angle B and angle C. So now what are we given? We're given that angle B is equal to angle C. So whenever in a triangle you have two equal angles, then the sides opposite to them are also equal. What is the side opposite to angle B? AC. What is the side opposite to angle C? AB. So AB is equal to AC. This is what we're going to prove. So let's begin. First of all, what is given to us? Given a triangle ABC in which angle B is equal to angle C. Next, what do we have to prove? We have to prove that the sides opposite to these angles are equal. What are the sides opposite to this angle? AB and AC. So we have to prove that AB is equal to AC. So this is very important. What is given to us and what we have to prove. Now to prove this, we have to do a construction. Same construction which we did in the previous theorem. That is, draw the angle bisector of A. So I'm going to draw the angle bisector of A. What does the angle bisector do? It divides the angle in two equal parts. So it's going to divide this angle in two equal parts. So let's say this point over here is D. So whenever we do a construction, do mention it over here. So construction. What is the construction? Draw the angle bisector of A and let it meet BC at D. So now we're done with given, to, prove and construction. So now let's begin with the proof. So see, what do we want to prove? I want to prove that AB is equal to AC. So how do I show two sides to be equal? Just show two triangles which have these sides to be congruent. So which is the triangle which has AB as its side? Triangle ABD. Which is the triangle which has AC as its side? Triangle ADC. So if I can show these two triangles to be congruent, then by CPCT, AB will be equal to AC. That is the logic. So let's try to show these two triangles as congruent. So we'll begin in triangle ABD. So in triangle ABD and triangle, this one, triangle ACD. So I want to show these two triangles to be congruent. So what all do I know? I know this angle is equal to this angle. So write it down. That is angle BAD is equal to this angle, that is angle CAD. What is the reason? AD is the angle bisector. So you can mention over here, AD is the angle bisector. Next, angle B is equal to angle C. So mention it over here. That is angle B, or you can say angle ABD is equal to angle C, that is angle ACD. What is the reason? Again given. That is, this angle is equal to this angle. So again, this over here is given. Next, AD over here is a common side. So AD is equal to AD. So I'll write over here, AD is equal to AD. What is the reason? Common side. So now what do we observe? In two triangles, whenever two corresponding angles are equal and one side is equal, the two triangles are congruent. So basically I can say over here, this implies triangle ABD is congruent to triangle ACD, right? See, angle B is equal to angle C and angle A is equal to angle A. What is the criteria I've used? I've used the angle side criteria. So see, this is nothing but a special case of the angle side angle criteria, right? So you can either use the angle side angle, that is, see, in a triangle, if two corresponding angles are equal, the third angle has to be equal. I repeat, in two triangles, if two corresponding angles are equal, third angle has to be equal. So this angle will also be equal to this angle. So what is the other criteria? Angle, side angle. I'll just show it. For the time being, remember, in two triangles, if two corresponding angles are equal and any one side, not just the included side, any one side is equal, the two triangles are congruent. AAS criteria, angle, angle, side criteria. So these two triangles are congruent. So I want AB is equal to AC. So let's get it from here. Label this 1, 2, 3, 1, 2, 3. I want the side corresponding to AB. So where is AB my congruence statement? First two letters. So first two letters will correspond to first two letters. What are the first two letters over here? AB. What are the first two letters over here? AC. So AB is equal to AC. Why? CPCT. Corresponding parts of congruent triangles. So hence proved. So hence we have proved that AB is equal to AC. So I repeat, whenever you have a triangle in which two angles are given to you as equal, immediately mark the opposite sides as equal. I repeat once again, whenever you have a triangle in which two angles are given to you as equal, immediately mark the opposite sides as equal, right? So I repeat this theorem once again. In a triangle, if two angles are equal, then the sides opposite to them are also equal. How do we prove it? Draw the angle bisector of A. Prove these two triangles to be congruent. Angle, 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 side. So by angle, angle, side criteria, these two triangles are congruent. Hence by CPCT, AB is equal to AC. So this is how you prove this theorem. In general, whenever we have a question in which you are given a triangle, if two sides are given to you as equal, mark the opposite angles as equal. If two angles are given to you as equal, mark the opposite sides as equal. That is the first thing you'll do, right? So we'll practice this in the upcoming examples. So previously we proved this theorem by angle, angle, side criteria. Now let's say you're not comfortable with angle, angle, side criteria. Then what will you do? Simple. See, I showed these two angles to be equal and these two angles to be equal. So let's say this over here is X. So this will also be X, right? Let's say this over here is Y. This will also be Y. So now let's get the value of this angle. So how do I find this angle over here? See, look at triangle ABD. In a triangle, two angles are known to me. How do I get the third angle? Angle sum property. So apply the angle sum property in this triangle. So we have in triangle ABD, what is the angle sum property? This plus this is 180. So X plus Y plus this angle, that is angle ADB, is equal to 180. What is the reason? Angle sum property. So get angle ADB from here. It is 180 minus X minus Y. Correct? Similarly, in this triangle, that is in triangle ADC, apply the angle sum property. So X plus Y plus this angle. So we have X plus Y plus what is this angle? Angle ADC is equal to 180. Angle sum property. So what is angle ADC? So what is angle ADC? It is 180 minus X minus Y. I want you to compare these two values. 180 minus X minus Y, 180 minus X minus Y. So when the right hand side is the same, left hand side is also the same. So basically angle ADB is the same as angle ADC. So what do we get? This implies angle ADB is equal to angle ADC. So these two angles are the same. So now once these two angles are the same, what is the criteria you can use? Angle, side, angle. That is, since these two angles are the same, we can use the criteria angle, side, angle. So in case angle, angle, side is not clear to you, just show using this over here that these two angles are equal. Once these two angles are equal in these two triangles, use the angle, side, angle criteria, show them to be congruent. So this is another way by which you can prove this theorem.